So in a queue data structure, same just like a stack, we are creating that queue. That is also we are representing with the array only. But first of all, how can we represent the queue? We have already discussed, if it is a stack, all the stack operations, nothing but the main two operations, either you are inserting or you are deleting that information, both we are doing from the same end only. That is the top of the stack. We are using that variable is a top. We use only one variable, that is the top of the stack. Top of the stack. But here, if it is a queue, we are representing, just you need to analyze as a normal queue. It's like a queue lines are there, no? Queue lines, in the same way we need to analyze. Just here it is representing index. If you want to insert, you are inserting from the rear. Insert from the rear. That is okay. Or if you want to delete, deletions from the front. Delete from the front. Insertions and deletions. So in stack, we use only one variable to perform insertion and deletion operations. And here we use two variables. One is a front, second one is a rear. Front and rear. This is what queue. And here one more important point. In queue we need to understand, front is always fixed. That location will not change. Front is always fixed. This is a very, very important one. Very important one. Okay, see, for example, at the box office counter is there. So people are entering into the queue and they keep on moving like this. They keep on moving like this. And then simply they will get the ticket from the counter. They will get the ticket from the counter. Okay. And they will come out. They will come out. That is. Okay. Here it is. So that's why the counter location will not change. Okay. The counter, that counter location will not change. That is called front location is fixed. Whenever we are writing the code, we have to write the code using that same concept only. Using that same concept only. First I'll explain that code with the diagram. So as usual, first we are taking that size. Any size you can take. Initially, I'm taking that size is a 5. I'm creating that array. Integer array. But only that array name instead of ARR, we are giving that word is a queue. New integer of size we specify. New integer of size. Then that queue will be created with the size is a 5. With the specified size is a 5. Queue is a created. Index as usual. We are representing 0, 1, 2, 3, 4. 0, 1, 2, 3, 4. This is the way. And in this one, we already discussed that front always fixed. So don't change the value. And rare, I'm giving that -1. Rare, I'm giving what? -1 is a 1. Just like a stack, simply we use. So here, front, I'm taking 0 because which is always fixed, which is always fixed. Next one, rare only will change every time, just like in a stack top value. Rare starts with a -1. Consider. Okay. Now, as usual, coding we are writing. The first step, we are inserting the data. Sir, I want to insert. I want to insert value is a 10. It's the same story. Just increase the rare value. Rare plus plus, rare plus plus. So Q of rare equal to that 10. Rare plus plus. So rare value becomes 0. Rare value become 0. Into that 0th location will insert. Sir, why it is inserted at front? No, just imagine. The person entered into the queue from the rare. Whenever the queue is empty, the person will go and will go. And the person will stay here only, no? Will stay here. That is the way we are representing. Is the first person stay here. In the same way, insert, insert is a 20. So we keep on doing like this. R plus plus is a Q of rare. Always is the same story. 20, 30, 40. Suppose is a rare value become 1. Into that we insert 20. Next one, rare value become 2. We insert value 30. Rare value become 3. Here it is, I'll insert 40. Rare value become 4. I'll insert that value is a 50. Okay, so we keep on inserting like this. 30 we insert, 40 we insert, 50 we insert. It's a full same story. When you can say that the queue is full. If that rare value equals to size -1. Same condition. Simply we can say that queue is full. We can say that queue is full. So whenever you are inserting, every time we need to check the condition. Every time we need to check the condition. So based on this condition, we are writing that queue is full. Insertion is easy. Insertion is very easy. Display also easy. Only deletion will take time. What is that? See. Display. Whenever you display, first we have to check queue contains elements or not. If rare equal to -1, if no one is there, directly you can say that queue is empty. Look at this. As soon as you created that variable, what is the rare value? -1. Rare value -1. That is. Into that rare, if elements are not there, directly we can say that queue is empty. No, if elements are there, starting from front is 0, na? From front to rare, display all elements. Simply repeating the loop for Index starts from front location. Always front is 0. It's fixed. I less than or equal to rare. Rare is a 4. I plus plus. Simply you are printing. Simply you are printing that Q of I. Q of I. This is the one. This is for displaying the data. This is insertion data. Okay, this is display data. While insertion, we need to check Q is full or not. While displaying, we need to check Q is empty or not. Empty or not. Sir, peak element also we are printing. Peak element also we are checking. If Q is not empty, just a message already we know. Q is not empty. Directly, we are printing that one peak element. Peak element means what? Front element only. Just a Q of front. Front element is a peak element. Is a 1. It's the same story. Whenever you are checking that peak element also, what we have to check? What we have to check that Q is a empty or not. We are checking if Q is empty. If Q is empty, then you cannot print. If Q is not empty, this one, if not empty, logical. Q is not empty, we are printing. Final thing is what? Deletion is very, very important in Q. Deletion. What will happen? In this queue, generally, again, general thinking only. Suppose in a queue line, 5 people are there. They are getting the tickets. The first person got the ticket from the counter and the first person left. Then what will happen? Will counter will move? See, whenever you see that code in online programs or anywhere, simply they will write a front plus plus. That is wrong exactly. Counter will not move. Only that people will move. Second person will go to that first location. Third person will go to the second location. Fourth person will go to that third location. Fifth person, last person will go to this location. General thinking in queue line, what is happening? We have to shift the elements. Sir, shifting so much time it will take, na? Yes, that is only the disadvantage. Lot of disadvantage. We should say limitation. That is only the limitation. That's why they introduced the concept of circular queue and double-ended queue. In circular queue and double-ended queue, front also will move, but in normal queue, in linear queue, front is a fixed. It will not move. We are learning now linear queue. Sir, how to shift the elements? See, once first element deleted, how can we code it? Suppose if that queue is not empty, first we are saying that deleted element is a deleted element is a queue of front. That front location element we deleted. That front location element we deleted. Okay. After deleting that front location element, we have to shift now. How can we move from 0th location to, or from first location to rear location? First we'll go to 0, second will go to 1, third will go to 2, fourth will go to this one. Up to rare. This is rare, not last. It's a rare. Okay. So we have to repeat the for loop starting from 1 to up to rare. I plus plus. What will happen? Look at this. Into q of I minus 1, q of I value will store. Observe this. Sir, what is I? I is a 1. 1 means first location element. 20. 20 will go to which location? 1 minus 1, 0th location. So 20 will store here. Next, I value will increase. Is a 2. Second location element will go to 2 minus 1, 1. So 30 will go here. Next, 40 will go here. Next, 50 will go here. 50. Then whenever rare person is in a fourth location, now rare person is moving to third location now. So rare value we should decrease or no? This is important. You have to decrease that rare value. That last point is very, very important. Everyone will miss this point. Rare minus minus. Because that last location person will decrease. Last location person will decrease. That is the one. Okay. Only thing is what? Whenever you are deleting, shifting elements takes time, of course. That is only that limitation. That is only called limitation. Shifting the elements. Shifting the elements. This is the way we need to understand. This is completely called queue implementation. Now just I'll show you how can we write queue implementation. First I'll show you. Then how to implement with the methods also I'll explain. If I write that second time, then it will be easy for you. First directly I'll write just like how we have written that stack in the last class. Everything I'm collecting, reading from the user. So I'm creating the object. I'm creating the object system.in. Next one, I ask all the details one by one I'm giving, but while true, its condition is true. It's queue operations, but sir, where is the queue? We have to create that queue. First, I will ask, enter size of the queue. Enter size of the queue. This one. Okay. How you will get integer size equals to sa dot next in top. Next in top. With the help of that size, we have to create the queue now. Integer, it's an array. Q equals to new integer of size. New integer of size. And once Q is ready, we have to take two variables. Front is always fixed. Rear will move. Here I'm just giving that message. Q is ready. So you can start doing operations. You can start doing operations. The first operation, insert operation. is a second operation, is a delete operation. Next one is a third operation, peek, nothing but displaying the first element. That fourth operation is a display. That fifth operation is an exit. That's it. The five operations we are providing. Five operations we are providing. Here, how can we execute this? The first we ask is the same, enter your choice. Enter your choice. Right? Now I'll ask choice equals to SA dot next row. So based on the choice, if choice equals to 1, what to do? If choice equals to 2, so what to do? Else if choice is a 3, else if choice is a 4, else if choice is a 5, if other than 1, 2, 3, 4, 5, just giving that message is error, invalid choice. Is a invalid choice. If the choice is equals to 5, just giving the end of program or end of queue operations, just break. Now one by one, I'm explaining. If choice is 1, we are going to insert. So first we ask, enter element to insert. Enter element to insert. Integer element equals to scan dot next int off. How can we push? How can we push means what? First, you need to increase the rare value, rare plus plus. And then we are writing what? Q of rare into rare. That element is added. Just giving that message is element pushed or element inserted. But sir, how can you do all these things? Directly, you cannot. First, you have to check. How to check? If that rare value whenever reaches total size minus 1, we can say that Q is full. Q is a full. Else, if Q is not full, then only we insert. Rare value is initially minus 1. Rare value is initially minus 1. And after taking that rare value, we are giving that value, nothing but we are inserting that value into Q. Inserting that value into Q. Okay, just one sec, small call. This insertion code I have written here. And the remaining is a choice to is delete peak display. First I'm writing the peak. If that rare equals to minus 1, when it initially, as soon as you started also, rare value minus 1 only now. So by that time, we can say that Q is empty. Q is empty. else just here, this one re is for peak element. Peak element means what? That front element we are printing. That is only called peak element, is a Q of front. Q of front. That is the same one. Choice 4 is a displaying the data. While displaying the information also, first we have to check that Q is empty or not. If Q is empty, it's the same. If not, that Q items or Q elements are, we already discussed. Index starting from 0 you can give or front you can give, because front is always 0. This is the best way to understand. From front to rear, how many elements are there in the queue? We are simply printing. We are simply printing Q of I. And the final one is a deletion. Whenever you are going to delete, by that time also you have to check Q is empty or not. Q is empty or not. If Q is empty, directly we can say that. If Q is not empty, first you have to show that item deleted. After that, we have to shift. For that, starting from first location, nothing but front plus 1 you can write, or 1 you can take directly. Less than or equal to rear I plus plus. Every time that first location element, nothing but ith location element, will move to I minus 1 location. This will repeat up to rear. And once all people will move, finally that rare person will move. Rare minus minus. Rare minus minus. Just run the code. Enter size of the queue. 5 I have given. Yes, queue is ready. Performing all the operations. I keep on inserting. 10 inserted. Again. 20 inserted. Again. 30 inserted. Again. 40 inserted. Again. 50 inserted. Again. Saying that message is a queue is full. I want to display all elements. Queue elements 10, 20, 30, 40, 50. Peak element means what? First element. Peak element means first element will give. If you delete 2, look at this, deleted 10. Now peak element is a 20 because 10 already deleted now. 20. That remaining elements are 20, 30, 40, 50. Sir, I keep on deleting 2. 20 deleted, 2. 30 deleted, 2. 40 deleted, 2. 50 deleted. When that last one also deleted, rare become minus minus, that is minus 1. 2. Look at this, Q is empty. 5 is for exit, end of the program. This is the way we need to perform queue operations also. Stack operations. In the same way, we perform that queue operations. Okay.